Using linear regression for prediction. So nowadays, linear regression is one of the major, if not the main tool for both analysis and various types of predictions. And we're going to use an example here with possum, the animal possum, but hopefully you can see how this approach can be used for all kinds of phenomena in the world. So we have one variable here, total length, and the total length of the animal. And each dot is a possum that has been analyzed. And here on the y-axis we have head length. So we're observing a linear relationship here, a positive linear relationship. The higher the total length of the possum, usually the bigger the head. Now, there's already an equation estimated here for us for this line over here. And actually, we're not going to get to how this line was estimated from the data. We will deal that when we talk about least squares regression. But we were able to find a line here. This line was provided for us, and the equation of a line rather. And the equation of a line, as you may remember from basic algebra, has the y variable on the left side equals the, as I mentioned before, the intercept. This is the y-intercept, 43 here. So when x equals 0, when x equals 0, what is y? Y equals 43, because 0 times 0.57 is 0 plus 43, then y equals 43. The hat here means it's an estimate. So notice how we kind of got rid of that error term. So the hat refers to an estimate, because notice how the line is not, all the points are not on the line. So the line is just a trend. It's kind of an average. And this 0.57 here, actually without the x, just the 0.57 is the slope of the line, right? So every unit change on x, increases the slope by 0.57. So how do you use this for prediction? Well, suppose you want to know what the head length of a possum is, that is 80 centimeters of total length. So something like over here. You found a possum and it's 80 centimeters of total length. Well, if we put it on the line, we can see that it's going to be somewhere right over here. So what is this? 86, 87 or something, or this is 85. So this must be about 88. But we can also calculate it directly. So it will be y equals 43 plus 0.57 times, this is times x. So don't confuse the times with x. 0.57 times 80. And then you see the results in the book equals 88.6. We could see it sort of in the graph where it is, but we also can identify it in the line. So this is how you use linear regression to make prediction. And we could do it in other contexts too, of course. So for example, in the stock market, maybe you see a stock with this relationship here. So on the bottom, we have time. On the top, we have the price of the stock. And then we see a linear trend and we create a line. Now, I don't have the actual slope of this line, but this can be usually automatically calculated by the formula we'll talk about later. And then so it is December, the price is somewhere over here. Let's say this is 10 and then 20, 30, 40, and so on, 60. And then so in December, the price is at $10. So, and in the end of December, the January, the price is maybe $80. So what is going to be the price in February, right? The price, if we just follow that trend, we can predict the price based on this linear relationship. And we can know that in January or February in the future, the price is going to be at $90 or $100. Of course, lots of things in the world don't work like that, certainly not the stock market. So just because you estimated a trend going up like this for a certain period of time, doesn't mean that it's going to continue going this way. So these are some issues with linear regression prediction, but some of the basic ideas about it. Next, we're going to be talking about residuals.